Coming up on This Week in Radio Tech, our guest is Alan Jurison. He's going to explain to us why it's so important nowadays to make sure that your FM and your HD1 on HD radio are in perfect alignment. It really is more important now than ever. Coming up on TWiRT. TWiRT is brought to you by BSW Broadcast Supply Worldwide with big discounts and easy overnight shipping. And right now, it's Happy New Gear at bswusa.com. By Direct Current Broadcasting Newsletter. Get Direct Current in your inbox every Thursday with technical pointers putting you and your facility at an advantage. And by Virtual Radio from Lavo. See Lavo Virtual Radio in your future at lavo.com/TWiRT. Welcome into This Week in Radio Tech. I'm Kirk Harnack, your host. Glad to be here. And this time here is at a little radio station in Mississippi. This is the show where we talk about everything from the microphone to the light bulb at the top of the tower and all the stuff in between. And we have a lot of in-between stuff to talk about today, even some of the feedback stuff to talk about today. What I'm talking about here is one of the subjects is keeping your HD and your analog in alignment. And for a small town operator like me, that really hadn't been a problem because we're not HD. But some of my stations will be going HD. So Alan Jurison will be along here in a minute. Let's bring him in now and say hi. Alan, welcome in. Glad you're here on This Week in Radio Tech.
Hi, how you doing?
I'm good. Glad you're here. Where is here for you?
Here this week is Syracuse, New York, which is where I'm based out of.
Okay, well, good deal. And as I recall, I saw an article, I guess it was in either Radio World or Radio Magazine, that you had written about HD and analog alignment. Is that what prompted me to get in touch with you again?
Yeah, probably. I mean, I've been very active with the NRSC Time Alignment Committee and NAB Tech Committee, working on time alignment with all the, between the different station owners and manufacturers, et cetera.
Oh, this is good, Alan. I didn't even know there was a committee to talk about this. So this is going to be a good show.
Really exciting.
I'm going to need you to kind of walk me through, how it got to the. There must have been a problem that prompted the formation of a committee to solve it and see what we could do about it. And I'm guessing that there were. I don't mean to get my powder wet on the way to keeping a secret here, because we're going to break for our first commercial in a second. But I'm guessing that this wasn't a big problem when HD started, or it wasn't foreseen as a problem, and then alignment along the way became a problem. And that's what we're going to explore and see what the solutions are. So we're delighted to have Alan Jurison as our guest today on This Week in Radio Tech. Chris Tobin has the day off. He's actually got a pet emergency. So we're saying a little prayer for Chris's little pooch and hope everything comes out right. So there you go. This Week in Radio Tech, episode 378, is brought to you by our friends at Lavo, L-A-W-O, lavo.com. And when you go to their website, if you do me a favor and let them know that we sent you, go to lavo.com/TWiRT. And that will take you right to their webpage that has their radio-centric products. And, one of the topics that we've talked about here on the show and is popular at all the trade shows is the topic of virtual radio. It means different things to different manufacturers and different users. Well, there's a virtual radio webpage that you'll find at the Lavo website, and it describes what Lavo is thinking about virtual radio. For example, there is a product called Edit VO. It's audio recording for broadcast, PC-based. Of course, there's lots of that available, but this is easy and intuitive, and the workflow works right into the Lavo workflow with audio over IP. There's also their system called Relay VPB. It's virtual audio handling. Now, there's a new way to talk about audio handling. It's a virtual patch bay. It's a Swiss Army knife of PC audio handling, and it can be very helpful when you've got sources and coming in from all over the place and all kinds of destinations. Having such a patch bay that's really easy to understand is very cool. Then there's Relay VSC. That's Lavo's virtual sound card solution, providing, get this, 64 channels of bidirectional Ravenna and AES67 streaming in the Microsoft Windows environment. Wow, 64 channels in and out. By the way, they also have a 64-channel driver for the Mac OS, and I'll be trying that out with some interoperability testing myself in just a few days. There's also a product that they've had along for quite a while now at Lavo. It's called VisTool. And that lets you build user interfaces. Now, I got to meet with some executives from Lavo a couple of years ago. And this tool is really a big part of broadcasters creating their own solutions to workflows. Every broadcaster has different ideas about how they're going to get something done, whether it's remote voice tracking, remote reporting, one-to-many programming, distribution, and then local insertions and controlling all that either in real time or remotely. Well, this tool is the tool that can get that done. In other words, you can build your own panels to show you what you need to see. Monitoring, remote monitoring, local monitoring, and faders, volume controls, lots of easy ways to make buttons that show state, that show status, and perform functions, perform commands. So virtual radio is one thing that Lavo is really into, and they want to show you their ideas about virtual radio. Well, the good news is there's lots of information on their website, so you can go to their website at lavo.com/TWiRT. Lavo.com/TWiRT. Click on the virtual radio link, and it'll take you right to the page that you've been seeing there on their website. And you'll find out more about virtual radio. Again, everybody's got their own ideas. Lavo's got their ideas, and it's really interesting the progress that they are making towards getting this done. Virtual radio from Lavo. Thanks, Lavo, for sponsoring This Week in Radio Tech. All right, Alan Jurison is our guest. Chris Tobin is off, and I'm here, and I guess I should say where here is for me today. I'm not in my usual digs. I'm in a little town of Greenwood, Mississippi. And I said, well, where's Greenwood, Mississippi? And by the way, Kirk, I thought you had radio stations in Greenville, Mississippi. Well, I do. And the two towns are, 50 miles apart, something like that. Kind of confusing having a Greenville and a Greenwood. In fact, I started my TV weather career in this area, and I always we'd give the weather for Greenwood and we give the weather for Greenville. It's just a local thing. If you've ever heard of Viking ranges, those beautiful, gorgeous, solid, stainless steel and cast iron stoves that all the famous chefs do amazing cooking on, and they're available for your home or for your business, for your restaurant. Viking ranges, they're made right here in Greenwood, Mississippi. So that's one of the things that Greenwood is famous for. And pretty soon it's going to be famous for our new radio station. It is Kix 92.7. WMYX is the call sign, WMYX. We call it Kix 92.7. It plays contemporary country music. And it's been on the air for a little while with the automation at the transmitter site. And tonight, we're moving the automation system. It's a Rivendell. Tonight, we're moving that to this room. I'm in right here, and it's a one studio radio station, and this is our new console we just installed. So that's what I'm doing here, Greenwood, Mississippi. And anyway, it's been a whirlwind trip. Got here about 48 hours ago and got the control room just about ready to go. So that's what's happening with me. Alan, tell me what has been on your plate lately.
Well, we've been increasing our HD monitoring of all of our stations. We did a big push for that towards the end of last year. We're finishing it up. Basically, we installed continuous, nonstop HD monitoring on every FM HD station that we have. So that's been a big project that spent the fourth quarter and just wrapping that up now. We have over 95% of them installed.
I'm guessing HD monitoring has been a problem. I can't tell you how many times I have heard of or I have tuned in to an HD station and there was nothing on, or the automation was messed up in some way. Nobody was listening to it. And that's understandable when the tech was brand new and there were no radios out there. But now I guess there's enough listenership where monitoring is pretty important. Tell me how you guys came to the business decision to put that effort into it.
Yeah, well, as we're seeing in some markets, the penetration rate of automotive radios with HD is increasing. And what we found is that overall nationally, that number is about 15%. But when you look at some specific markets like New York, Miami, and LA, those three markets, 25% of registered automotive vehicles in that market have HD radio. So you have, and then you have a lot of markets that are between, let's say, 18 and 25%. So you have 1 in 4 or 1 in 5 listeners listening to your station in the car, and they have HD radio. And a lot of them don't know that they have HD radio. They just bought a car, and it just has this thing, right? It has all these things. Well, what we're finding is people get in those cars and they find that the time alignment and the listening experience hasn't been what it should be. And they oftentimes, if the time alignment between the analog and the digital is incorrect, it'll skip or it'll cause some sort of blending artifacts, audio problems, and they don't know that that's their radio station that's the problem. A lot of times they think it's the car. And the biggest problem has been is a lot of people bring their car back to the person they bought it from and said, hey, my radio's broke. So that's been a big problem for the industry. That's the biggest number one nag from automotive is that this industry on the transmission side hasn't really taken time alignment as seriously as they should be. And part of our problem was we were really lacking the tools to be able to do that. And there's been some tools that have entered the marketplace the last couple of years, and stations are starting to buy them and explore them. But the vast majority of stations out there are kind of in the exploratory phase. They know about the topic, but a lot of people haven't done things about it. So we're trying to increase that message out there through the NAB and also through the NRSC, the National Radio Systems Radio Committee, and creating guidelines for station engineers to be able to look at what equipment they have that they probably put in 10, 15 years ago, and how can they best optimize it for time alignment and make sure that time alignment is stable.
So, Alan, kind of bring me forward through a little bit of history. As I've mentioned, I work pretty much in small markets, and we're deciding to get our first HD just pretty much so we can run a translator with separate programming.
Right. That's been a big boom for the technology on the transmission side.
Yeah.
Just smaller markets. So, I'm seeing a lot of that.
Some years ago, I was asked to look at a station's HD setup and align the HD1 with the analog. And I found it fairly easy to do. I guess I had a monitor, whatever. I got to hear a split earphone. And
a lot of the broadcast monitors you can put in split level mode, and it'll have the left channel will be the analog and the right channel will be the digital.
And I was able to dial it in, and even when it was real close, I could hear it was wrong, and I felt like I dialed it on. I guess it was on the exciter. Where would I have been dialing this in? Well,
it depends wherever you're doing your analog diversity delay. So the original ones, it was done in either the exciter or, and the newer technology, a lot of people will do it in the exporter, or actually the most common place, especially in major markets, is to do it in the audio processors. A lot of people, you already have this device in line. All of the audio processors that do FM plus HD that have been out for over 10 years can do the delay as well. And that's really been the most reliable place to do the delay. So people will set it up there and listen in split mode. That's been kind of the old way we did it. But what we found is just like processing and station sound, there's engineers that have the golden ear, and then there's the ones that don't. Time aligning to perfection, to what's required to actually make those blends sound good, is very hard for the average person to do. I can't do it without some sort of automated tool. So, 10 plus years ago, there really was only one product out on the market that I'm aware of that kind of measured it for you and gave you a number, and that was the Automat Golden Eagle. And a lot of people bought them, and they had some problems. We actually have found out more recently that the numbers that it was giving you, a lot of people just kind of took the number and they plugged it in their processor or whatever, and they just kind of went home. Well, and they didn't listen to the blends. And I think that's how the industry really did. They set it up, it sounded close enough or good. But the problem is the whole industry wasn't focused on blending happening a lot. They just thought it kind of needed to be in the ballpark. If the audio's close, it blends once and that's fine. But as we found is automotive, people are out in their car, and if they're in the fringe of the viewing area, or the listening area, they're blending back and forth all the time. So you'll have digital and then you'll lose it, and it's coming back and forth. And that's actually when I first found out about this. as HD was becoming very popular, there was a station that was kind of a rim shot to the market I'm in. It's all talk and all talk-based programming. And I live like right on that 60 dBu contour between work and my house. And so if you were to listen to it, the thing was constantly going back and forth and back and forth. And that's what's objectionable. So it's not everyone thinks of this as they live right near the transmitter site and maybe the urban part of the market where the HD doesn't go away, and they turn on the car and it blends once and that's it. But as they move around the market, it does blend more often than you might think, and that's why it's really objectionable. And of course, the average person that buys a car doesn't understand any of this. So if the radio is making those noises quite often, then they think something's wrong with the radio, and that's why they're bringing it back to the dealer saying, "Hey, fix my radio."
So thinking about this spec in milliseconds, and by the way, I guess we should back up just a hair to explain to those who don't know why this blending and why is time a problem? I mean, aren't you transmitting analog and digital at the same time? And of course, the answer is well, not quite, because analog the analog can happen almost immediately. There's no real delay in analog, but the digital takes time to encode and takes time to decode. It's a simple way to put it. There's buffering. There's making sure all the data's there. And so in the end, the digital, when your radio is listening to HD, you're listening to audio that started to be encoded about 9 seconds ago, right?
It depends on the age of your transmission hardware. So the original stuff came out and it was about 6.5 seconds, and they found out that, you should probably, from the broadcast side, we needed more buffering because we were having dropouts. Like, we weren't able to reliably deliver data from point A to point B with that. So they've added more buffering. So then the next generation came out, was about 7 and 0.88 seconds was about the target, like 2005, 2006. And then all the newest hardware that comes out there, if you buy a brand new transmitter, from like Gates Air or Nautel, everything's going to land up around 9 to 9.2. And the big changes is they've added more buffering on the broadcast side to make up for some of our network challenges that we have on the broadcast side.
Now, I should point out that the receivers, those have a fixed amount of difference between the analog and the digital, because you can't go you can't go update the firmware in all these radios. So they're fixed.
Correct.
And do you have any idea what is their difference between analog and digital that you have to make up for in the end? You
really don't. You don't have to do that. Those all generally have a common response. It's part of the iBuiquity, which is now Xperi, but their chipset. So there really isn't too much of a concern there. It's really on the broadcast side. So we were talking about the actual spec. So a lot of people really didn't know what it was, but what it comes down to plus or minus 3 AES samples at 44.1 kilohertz, which is the HD reference. So you're allowed, 0 is obviously the perfect target. You're allowed plus 3 AES samples and minus 3 AES samples. And the reason why I talk more about AES samples and a lot of the new products that are coming out there are focused on that is a lot of people are getting confused with time, because if you use the time, device 1 does it in milliseconds, device 2 does it in seconds with a long leading decimal point. So, 3 will do it in microseconds. So you can't plug in one number from device 1 to device 2, or this monitor tells you're off by this. The numbers are all over the place, but AES samples seems to be a good way to standardize on it. So we've been talking more about that, but the actual spec basically is plus or minus 68 microseconds. So that's what three AES samples ends up being. So you're allowed plus 3 microseconds, or 68 microseconds, and minus 68 microseconds from the center point of 0.
Wow, which is what, 0.068 milliseconds, is that right?
Yeah, or there might be an extra 0 there too. It's tough. It's really tough, and that's why the precision hardware of today to monitor is so crucial. And also the industry is kind of really nudging towards doing automated time alignment, so that it takes the engineer out of the equation. And if there's some component in your system, we can actually, maybe that would be a good discussion point a little bit later on, but there are things in the system that can drift that are out of your control. And depending on the topology and the hardware that you have purchased and assembled and how you've assembled it, can really dictate how reliable that is. So for some people, they've been setting it manually, and 5 seconds later, it's a different number, and they didn't know that. It was a moving target. And other people, it's pretty stable, depending on the topology and the hardware that's in use of the station, but it changes over time. And those things are usually generally like a reboot. A reboot can be a problem. So, you reboot the exporter or the exciter. And when does the reboot happen? Usually when you're not there, it's, there's a power bump, right? Power bump, it's all the transmitter site. You got a little bit of time before the generator switches over. Maybe the UPS wasn't working. We find a lot of exciters, particularly exciters. People understand the exporter is a computer. And yeah, I should put that on UPS, but a lot of the exciters were installed inside the transmitter. And unless you went out and modified the wiring to put the exciter on a UPS, a lot of them aren't on a UPS. So every time you have a power bump, your exciter is rebooting, and so it has to rebuffer from start. I mean, just imagine if you were trying to do a lot of people do audio remotes now with codecs, right? Just imagine if you're pulling out that Cat5 plug every 5 minutes, that number's going to move around on you. Yeah, and that's what's been happening.
So if you would help me understand one last thing from my limited experience. Years ago, I was asked to align a system, and I assumed, and it seemed as though the alignment was fairly stable. In other words, I went to the transmitter site. I
Do you know what product you worked with at that time?
I don't. I'm sorry. Well, you know what? It may have been Harris. It may have been a Harris.
Was it like the original Dexstar by chance, or was it after they moved to the? Okay, so the first and second generations, where everything was in the same box, the Dexstar or the BE ASI boxes, it's basically when we had a computer running the exciter. And that was the original stuff that was deployed from 2003 to 2005 timeframe. Yep. And that actually did work because the analog and the digital and all the components of it were in one box. There was no. I'm sure there could have been, a bad card, some tolerances or something like that. Something that would fail in it that could cause time alignment. But for the most part, those were stable. But what happened is the industry demanded flexibility, and so that. All what was in that box got broken up into 3 different pieces. You have the importer, you have the exporter, and you have the exciter. And what we ended up doing in doing that is breaking up a really time-critical sensitive system into 3 separate bins, and we didn't really spend a lot of time looking at the connections between them and making sure that that the networks were isolated, and a lot of times people wanted to put some of those components like the importer and the exporter at the studio because they were computers, right? They needed more help, reboots, etc. So they wanted to move them all back at the studio. And the broadcast industry, particularly on the radio side, has never taken radio data links, RF data links for IP seriously. So there's a lot of packet loss. There's a lot of jitter. All the things that are bad about internet encoding and the troubles that we've had. And it's taken years to get, audio codecs that worked well over the internet. None of that's been applied to HD radio. And basically, the system as it's designed today really works best when it's all at the transmitter site, all on an isolated network with, not a bunch of other stuff on it. And when you stray from that, now you're, if you've got it at the studio and you're also sending files back and forth or an audio stream back and forth on a data link between the studio and the transmitter site, that's all competing for time on the data link, and the packets don't arrive in a timely manner. And so you start seeing some sort of drift.
Just like even on this connection you and I are speaking on right now, there's a buffer at each receiving end of everything that we're doing here. Of course, all that adds up. Right. On a VoIP phone call, you've got a buffer typically 100 or 200 milliseconds, which is anywhere from 5 to 10 packets, 4 to 8 packets. Anyway, you've got all these places to buffer, and that buffer can change. So that, I think you're answering my question, and which boiled down to why was it stable with 2003 equipment, and why did it become unstable? And the answer sounds like, well, because we wanted convenience, we wanted to split things up, we wanted to be able to have lower bit rate data paths to transmitter sites, so we wanted to send already coded audio out there, but that induced the problems that we get in a packet switched environment,
Correct. Yep.
where we're sharing with other things. Sometimes you get a delay here or there, or a packet resend if you have to. So that introduced these variable delays, and now we've got to make up for those variable delays.
Right. And keep in mind, what I've found is the reason why we're able to do this over Skype and why FaceTime and all these things work on our phones is the telecommunications industry has significantly improved the performance of networks. Just remember, in the mid-90s, we were doing dial-up, and then we had our first cable modems, and now we have fiber, and we have LTE. We have all this bandwidth. The average, phone right here can just have 50 megabits or more of bandwidth whenever it wants. Well, we've never upgraded a lot of our radio station STLs, so a lot of them are sitting there at 256 kilobits or 512 kilobits. And so we're asking way too much out of that, and we have not really applied what we've learned in robust IP and video coding back to this system. And so it's kind of a confluence of all of those types of issues. And the real thing is what we found is it works all best when it's all sitting at the transmitter site. And that's what the NRSC guideline essentially recommends, is at least putting your exporter and your exciter co-located at the transmitter site, and you can put them on their own little network, and they'll stay absent of the reboots of a exciter rebooting or the exporter rebooting. They'll stay pretty much time aligned. When you set it and kind of forget it. But if you start moving that exporter away from the transmitter site, we've thrown really good links at it too. And it doesn't do very well with the jitter. It's just not as robust. And honestly, if you took pick anyone's IP codec in this industry, you took two of them and went from point A to point B, they'd be all over the place too with their time alignment. They won't be time aligned unless you actually, some of the newer audio codecs for there's products out there that are now being used for synchronous boosters. They're actually applying GPS timing now to the IP codecs, and those can, but that hasn't again even been put back into the HD system or a standard audio codec. And normally on a path like you to me and you to all our viewers today, it doesn't matter if it's moving around a little bit, because you're just looking at one thing at a time. You're just watching the stream, but you're not watching a parallel stream at the same time. And it's like, and that's our problem. So with HD radio is the customer or our listeners have a parallel stream. They have that analog stream available to them all the time, and then the digital streams coming in and out. And if those aren't perfectly time aligned for the blend, then you start getting audible artifacts of some sort, skipping, hollow effects. It depends how far out of time alignment you are.
It's like with HD radio, you always have a reference, and with most other IP things that we do, like, as you said, FaceTime or this very Skype call, or in fact, on this call, you and I are using two different brands of similar technology, but they're different codecs. You're on Skype, I'm on WebRTC, and so, but neither one of us has a reference per se. We're each of us, you and me, and our viewers are each seeing what we're seeing, and there's not enough aberrations in that to make it noticeable typically. But if you have a reference and something else, which you do with HD radio, and I'm not saying that the analog would be the gold reference, but that's the fallback. And then you can, so whenever you blend that, and I guess that's another thing just worth mentioning, it's because of the blend. And the fact that our heads, our ears, our listening, our brains are very sensitive to time jumps, right? If you're listening to a song and you hear an extra beat in that measure or a missing beat in that measure, your brain's going to go, huh? What? Wait a minute. Yeah. There were 5 beats in that 4-beat measure. What's going on? I mean, our brains. Yeah. Well,
it's really interesting. It happens on the video side of things. You mentioned I'm one of those cord cutters. I got rid of cable TV like a year and a half ago. It's been great. So I stream pretty much everything. I'm a big Syracuse basketball, NCAA Division I basketball fan, and I had people over to my house, and I have TVs in multiple rooms. It's almost like a sports bar. But you know what we have to do? We have to pick one TV that we have the volume up on. because they're all in different delays. And what I find is I actually, at the beginning of the party, right before the game starts, I stop all the streams, I get my remotes, I start them up so that they're basically in almost time alignment. But then over the whole first half, they all work with their jitter buffers and stuff like that. They all work. Sometimes one can be 30 seconds behind the other one. I mean, it's just amazing how much digital technology will drift around if you've separated it. So really the best way to do this with HD radio is put that exporter and the exciter at the transmitter site. Keep in mind, importer, that can go back at the studio because that's an HD2 or your data services. Those can move around all you want. You don't have a frame of reference, as you've mentioned. So it's not like you're trying to blend the HD2 into something else. So there's a larger buffer there, and it can move around, and importer to exporter connection is much more forgiving of these poor STLs we sometimes throw at them, IP links. Yeah. So it's all about frame of reference, and that's why it belongs up at the transmitter site currently.
And we would have terrible problems if, for example, codecs, as they have been designed, if they had been designed to carry left and right channels separately in different packets, we'd have a disaster on our hands. Right, but as it turns out, Fraunhofer and others have decided, what, left and right are pretty important that they stay time aligned, so we're going to put them in the same packet. We're going to interleave that data.
Yeah, so it's really interesting to see, and that's why we've had this problem. And for a while, as you said, the transmitters all got put on. There weren't a lot of radios out there. It wasn't a big deal. But now when you're seeing, 46% of new vehicles sold this year so far have HD radio in them. So all the new vehicles out there, a little bit less than half, they have HD in it. When you start seeing the market penetration, getting to 20, 25% in some places, people have this technology, and sometimes they're frustrated by it if your station isn't optimized for it. And so what we're really asking everyone to do is go to the NRSC website, download the guideline, and review it. And really, it's kind of a one-stop shop. It has every topology that's out there and shows you what's good about it, what's bad about it, discusses it, and shows you how you can fix it. Whether it be, really, as I said, the idea is we all really should work towards a model of automatic time alignment.
We'll put that link in the show notes. And Alan, if you can think to shoot me that by text or email, I'll make sure the right link gets put in the show notes. Hey, we're going to take a quick commercial break. And Alan, when we come back, I'd like to understand better from you now this automatic method of getting back in alignment. I'm guessing there's a feedback loop. It has to do with a monitor, maybe a mod monitor, and feeding back into audio processor or other stuff. So I want to hear about that when we come back. We're talking to Alan Jurison. He's with iHeart Media, iHeart Radio, and Alan is a technology whiz with iHeart. We've had him on the show before talking about RDS2 technology, and now we're talking about alignment of HD radio, especially the HD or the FM signal and the HD1, because those are the ones that blend back and forth, especially when you're on the edge of the digital reception area. This Week in Radio Tech, episode number 378, is brought to you in part by our friends at Broadcast Supply Worldwide. And look what just came in the mail for me. It's addressed to Kirk Harnack, WKXY, Cleveland, Mississippi. I'm everywhere. I'm part owner of 10 radio stations. I think I get 10 of these. The BSW catalog, and by the way, this is just their flyer. They have a full-fledged catalog that recently came out. By the way, if you go to SBE meetings in your area, you may get in your hot little hands a BSW catalog at your SBE meeting. We did in Nashville. Our friends at BSW shipped us a box full of BSW catalogs. Everybody went home with one. Great marketing, and we all had something to look at when we got back to our radio stations. Well, right now it's the Happy New Gear sale, and I think we have a website graphic to show here. Yeah, there it is. Hey, it coordinates. The Happy New Gear sale up to 50% off. They're also having a clearance sale that I really should mention first. There's a special clearance sale going on. Save over 50% on most items at their clearance center. You can choose from a wide assortment of specially priced gear, including certified B stock from Innovonics, broadcast consoles and mixers, audio processors, and more. But don't delay, because clearance items and B stock, when they're gone, they're gone. You can't say, can you get me another one of those? No. When they're gone, they're gone. And then, of course, the manufacturers and BSW, they might rather sell you something that was brand new. I guess maybe there's a better profit margin there. But hey, it's no good to keep gear around either if it's scratch and dent, or maybe it went out on demo. I know the folks at my employer, Telos, we have B stock from time to time. BSW takes advantage of that from time to time. And we can't sell it as new. It's got to be sold as B stock, and usually it's just in great condition, but it may have been put in a rack somewhere. So if I were you, I'd do a couple things. Go to the website, the BSW website at bswusa.com, and first of all, have a look at their clearance items. Have a look at what's on sale now in the Happy New Gear sale. Get it, new gear as in new year. Take a look at that, and then sign up for a catalog. Make sure they have your email address and your physical mailing address, and you'll get their catalog, which is just the industry standard reference. Look, I'm being honest here. Plenty of people look at the BSW catalog and then they call their favorite dealer. But BSW could be your favorite dealer if you just give them a call or order from the website. They do make website ordering easy and convenient. And I want to point out one last thing. If you're like me and you forget to buy something until the last minute, well, the BSW warehouse is in Columbus, Ohio. It's not in Tacoma, Washington, where their headquarters are. But they strategically, and they did this for us in the broadcast industry, they put a warehouse in Columbus, Ohio, near the Columbus airport, which is a huge hub for UPS. That means that, and there's a full staff there too. That's where they pick your order from on most products. So order online or call. If you do so before 7 p.m. Eastern time, if they have it in stock in their Columbus warehouse, and the chances are very, very good that they do, it can go out that night. It can be on a UPS plane that night, and you can pay for overnight shipping, later next day, 2-day shipping, 3-day, whatever you like. You can get it. And if you're like me, you forgot to order it until the last minute. And then bswusa.com to the rescue. Yeah. So I appreciate their sponsorship very much. Thanks a lot to Tim Schweiger and everybody, Brian Seeley, and everybody there at BSW USA. All right. Let's move on now. We're talking to Alan Jurison on This Week in Radio Tech. And Alan is telling us about HD radio time alignment and why that's become important because of the number of HD radio listeners out there. And Alan, just to make sure I understand, you said that with HD2 and HD3 channels, or even HD4, as some people do, the alignment is not a critical thing because there's no comparison. Either you have the signal, or if you're too far away, you don't have the signal, and there's nothing to align to, right?
That's right. There's no issues there, and the importer, you can add additional buffering towards it if you have a link that has a little bit of issues. It's far more tolerant to imperfect networks than the HD1 is.
But if you're listening to the FM and then blending over to the HD1 in a good signal area, and you're driving around, we all know there's going to be places where it's going to blend back to the analog. And the thing about analog, the signal can be degraded and your brain doesn't mind it that much because it's still listenable to a certain degree. But with digital, if there's not enough good ones and zeros to recreate from the coded audio, recreate the audio that you want to hear, then the codec, the decoder, can't do anything with that, and you end up with that kind of audio or no audio. And rather than doing that, since we've got the FM anyway, let's just blend over to the FM. And to help make it more seamless, the people at Ubiquity ended up making it a little blend over. By the way, is that blend a consistent amount of time from one brand of radio to the next, or does it vary a lot per manufacturer?
So the original chipsets for most of the radios we're familiar with, it was. But what they've done now is, since this has been such a hot button issue, the car manufacturers asked Ubiquity, which is now Xperi, asked them for some more control over this. So the latest chipsets that are in the hands of automotive companies, they haven't necessarily all implemented them yet, but it basically has some tweaks to that. So they have a stock blend that is what comes with the firmware, the default setting, which is very similar to what we're all familiar with. But they're basically giving the automotive manufacturers and their partners that make the radios for them keys to the API to that, to be able to maybe tweak that a little bit. And in fact, without getting into specifics, some manufacturers are working on it. Some of those products you can actually buy a car with that new technology in it. And the overall concept is what they're doing is they're I like to, since we all have a bunch of broadcast engineers, they're treating it, basically building a hysteresis loop into this, and they're treating it kind of like your generator transfer panel. So as soon as you lose digital, blend to analog. But before I go back to the digital, I better make sure it's going to be there for a while and it's been reliable. So that's kind of a new thing, and Xperi has been giving advice to the automotive manufacturers that have been interested in that, and I think we'll start seeing if you can't buy one today, very soon you can buy cars and you'll start noticing. So maybe instead of them blending back and forth all the time, maybe if it loses digital, it's stuck in analog for at least 30 seconds or something like that before it comes back. Oh yeah, the digital's back. You're back in this coverage area. It's been reliable for the last X seconds, whatever it is. All right, I have a higher level of confidence that I can be in digital and it's not going to blend on me again. So I'm going back. So it's kind of building that hysteresis and that customization. The manufacturers have really asked for that, and Xperi has delivered on it. And I would imagine as time goes on, we'll see more vehicles that kind of take that how we've always known about blending the last 15 years into consideration. That a lot of that's going to get controlled and changed as next generation radios are implemented.
So it's important that the two be time aligned for a couple of reasons. First of all, no matter what the behavior of the radio is, whether it switches or blends quickly or blends slowly, if they're obviously out of time alignment, then you hear two different drum beats that are supposed to be the same drum beat. You hear things that are definitely out of whack. But even if the HD and the FM audio are just slightly out of time during the blend, and this is a case where a shorter blend would be better if there's just a little bit of mismatch. But
I think the blend speed will be the same. It'll just the recovery when it comes back. I think the speed, the actual crossfade, I think that's probably going to, I'm sure they probably let that customize too. I don't think the blend's going to be any slower or faster. I think that's really what we're talking about when it comes back. When it loses digital, when will it come back? I think is what most people are starting to focus on. But sorry, I didn't mean to.
Oh, no, you're fine. So just as, hey, if, engineers, Alan, you're pretty young, but old guys like me, we remember tape head alignment, right? And so if your tape heads are out of a line and you mix down to mono, your left and right tracks, you would have a comb filter effect, and that's
what you get when they're off. Yeah,
sure. So go ahead.
That can start as far off as close to that. And remember, I told you plus or minus 3 AES samples. You can start hearing it at 6 AES samples. You can hear that comb filtering from 6 to like 50 milliseconds or 50 samples. I've been normalizing everything to samples. A lot of the new products you're seeing out there start doing samples because it's a little easier, I think, to relate to from an engineering perspective. But yeah, you get the comb filtering effects all the way up to like 300 milliseconds, and then from 300 beyond, it starts hearing it's an audible time gap. You can actually hear the programming jumping back and forth, and if you're using on a talk station, you can hear whole words or phrases, again or double, or you can miss one in a sentence if it's too far off. And so that's been a big issue, and as I said, we're just trying to raise awareness. The NRSC standards.org website has the new G203 guideline, and we'll link that with the show notes here. And as I said, it's pages and pages of information, and the idea is that maybe you don't read all of it, but you go and you find the block diagrams that's like, oh yeah, that's how my station's configured, and how can I fix it? And you talked about how we start getting into alignment. Remember, we've spent a lot of our time talking about time alignment. There's actually 3 domains that we want to look at. There's time alignment. There's level alignment, audio level. You want the analog and the digital to be within plus or minus 1 dB of each other at any given. And the big one is phase alignment. You want to make sure that you're not 180 degrees inverted out of phase, so that when that blend comes in, you actually get a cancellation and a quiet spot if they're 180 degrees out of phase. So that's been an issue. As we found more about phase, another thing that was a big thing when we first started talking about IBOC and digital radio. Remember when all of that, probably original hardware you had, if you were using that Dexstar, there weren't integrated processors that took FM and HD and processed them in the same box. That didn't exist at the beginning of this. And so what people were doing is they were buying other processors. They had their analog processor with a composite output, and they bought a separate digital audio processor. And at first we encouraged, since digital doesn't have all the constraints, it doesn't have the analog noise and things, you don't have to compress it as much, you can leave it open. And we found that when you start doing dissimilar processing between FM and HD, we really weren't thinking about it. That hurts the blend. So you can have perfect time alignment, you can have perfect level alignment, you can be in phase, but if you have two separate dissimilar audio processors, when you blend, you can hear it. And that's also a problem. So the industry has really needs to work towards cleaning all of those up and buying newer audio processors that do FM plus HD in the single box. And that's a big thing that the NRSC recommends in the standard as well. And it's something we honestly, I think the whole industry kind of forgot about that. And it wasn't until we really started doing deep dives into this, going like, okay, this station is perfectly aligned, both in level, phase and everything. Why doesn't it blend right? And it ended up being, they may have bought, let's say, a brand new audio processor. And a lot of people, where is audio processing competitive? It's on the analog side of the dial now, because that's, again, where most of our listeners still are. So they may buy one of the top of the line audio processors, and they put it in their analog chain, and they leave the digital alone. The HD one, it sounds good enough. But now you have two totally dissimilar processing architectures on the FM and the HD, and when you blend that content, depending on the frequency content, that can cause a problem with blending too. So really, it's time alignment, it's level alignment, and it's common processing for FM and HD. That's really the big takeaways from the NRSC recommendations. Exporter at the transmitter site, and we also want to talk a little bit about the automated time alignment processes.
That's right. That's what I was going to ask about next. And I should mention, though, that even with hey, how you doing? It's visitors here. You build a new radio station, people come by. So even within the same processor, and of course I'm familiar with the Omnia product since they're my employer. The idea is you try to get the texture the same for both, so you have similar wideband and multiband processing. But of course, when it comes to the pre-emphasis and the limiting and any clipping that's done, you do one of them for FM, and you do look ahead limiting and other things for HD,
HD side,
for the HD side. So there's going to be a little bit of difference. The idea is, I guess, is to we've always taught is to keep the texture sounding the same, but of course you got that final tweak for the actual transmission technology is going to be different.
And we haven't found that to really be an issue. It's when you have, as I said, let's say you brought up the Omnia product line. We found in our research, we found Omnia 11s on the analog and Omnia 6s on the HD. And those are that's like apples and oranges. You can't do that. You cannot. It just does not work, because not only what we also found is the multibands are all at different frequency levels. Their delays, their attack and release times are all different. So what you get is this mess, and so you might have instantaneous while your overall phase relationship of the audio is in phase. You may have instantaneous, depending on the frequency content. Instantaneous differences in phase that when they blend, you have all this artifact. We've even found this. Let's say take two Omnia 6 processors side by side. We found that firmware matters and presets matter. So if what we've actually recommended for a lot of people that have, let's say, two Omnia 6s before Omnia had the EXI HD that did it all in one box. A lot of stations have two similar Omnia 6s. You know what? Since the FM was always the competitive, they always upgraded the firmware, and they're always tweaking the preset on the FM to make it, the loudest and whatever the program director wants. A lot of them didn't touch the HD box. So what what we found is a lot of the Omnia 6s that were on the HD1 are still on the original firmware, on the original preset that they did. And when you go to blend them, that's a problem. So what we recommend a lot of people to do, if they can't afford to go to combined processing right now, is take the Omnia 6 that's on the analog chain and find out what firmware version it's on. Make sure that the HD one is on the same firmware, and then copy the preset from the analog box to the digital box, and that solves a lot of that problem. And as I said, but you really got to have to match the exact same box, because many of you might know him, Russ Munshank from Ubiquiti, now Xperi. He calls all of basically an audio processor is a time machine. They're all time machines. You touch them, you can sit on the front panel and you can change and tweak this. And the delay, you can watch them on those precision products now. The delay is moving all over the place as you modify and tweak and jump presets or whatever you do. Everything you're doing is changing the delay. So they're basically time machines. And when you have two time machines, one on the analog chain and one on the digital chain, it's really hard to get them to be in sync.
So I hadn't meant to keep pushing away the subject, but I guess we better get to the last subject, which is how does this feedback? How does this work to keep them in line automatically?
So there are three, and there are more products that are coming out, but there are three major products that are out there. Two of them are inline external devices. So Innovonics makes a device called the Justin 808. And the TWiRT makes a box called the M4DDC, and those can go in either your analog or your digital chain, and essentially add and subtract delay as needed to keep whatever chain you have it in aligned with the one that doesn't have the automatic correction in. And then, so those are inline products. I believe at the show, Wheatstone announced that they were putting one in one of their processors, and so some audio processors are starting to offer it. And it's good. It's good to have options, because some people are comfortable with certain companies or devices in their air chain. I mean, and some people aren't. So it's good to have some options. So those are inline. So let's say if you had an audio processor that did it, or it would be an FM plus HD integrated audio processor. If it had a tuner in it or a control mechanism, it can go and change it. And then, as I said, external devices that you loop either the HD or the analog chain through that measure it. That's one set of it. The other one is, as you mentioned, also a broadcast monitor. Bellar has gone out of their way to add in their HD monitor a time alignment section where it can go send correction codes to a variety of audio processors. So it doesn't necessarily need to be, let's say, the latest Wheatstone that might have it built into the processor. It can work with the older Wheatstone devices that don't have that built in. It can also work with Omnia and Orban products as well. It's probably the most universal device. So you buy the Bellar monitor and you tune it to the station, and when it notices the time alignment is off, it sends the correction code to whatever device is in the chain that's providing the delay. And so some people have implemented those. So there's really a variety of products. There'll probably be more as time goes on. But the NRSC really doesn't endorse one particular manufacturer or method, but shows where the time correction could be placed in the chain.
So with several different brands of aren't there about 3 different brands of monitors that can provide this error signal, differential signal, and tell a processor how to correct? Does everything work with everything, or is it a matter of different manufacturers are shaking hands with different manufacturers so that, we have an agreement with this one, we have an agreement with this one? Yeah. What works with what? Yeah,
it's more of the latter. Really, if you go into the Innovonics world, it's a single dedicated appliance. And it doesn't send correction codes. It has to go in the air chain. It has to go in your digital or your analog air chain.
Right.
TWiRT has 2 devices. One is their M4 tuner, which can send correction codes to participating manufacturers they've worked with. And as I said, it's whoever they've partnered with to be able to do that with. And then they also have the M4 DDC, which can also go in the air chain. It's like the Innovonics Justin. It's a standalone device. And then Bellar is pretty much the standard as far as what works with the most amount of external devices. So the Bellar will never go in your air chain. It can just talk to the most amount of devices. So it can talk to even the exporter if you're running a delay through the exporter. It can, as I said, it can pretty much talk to any Omnia audio processor, any Band processor and any Wheatstone processor. And that's really, that's Bellar going out, really doing a lot of the legwork to make that happen. And doing a lot of the testing and stuff like that. So that if you want to not add anything new to your air chain, that's a good device to look at. He's even added, Bellar's even added a way for it to be able to patrol and maybe scan 4 or 5 stations and send correction codes to 4 or 5 different devices if you have multiple stations in your cluster. So that's one way to look at it. And then there's also the integrated appliance approach. And we've found, just through our own testing here, is that the integrated device is much simpler to manage. You don't have, and it can go. A lot of people are very worried, and they're precious about the analog air chain, right? That's where the money's still being made, and they don't want to do a lot of adjustments there. So what we've really been talking about is putting all of the time correction right now in the HD1. So you have it, you leave the analog and you leave it fixed at some value. And a lot of times, so we were talking about the latest stuff is, 9.0, 9.1, 9.2 seconds on the HD delay. Mm-hmm. So you go in the audio processor and you set it to 10.0 seconds on the analog, just make it even. Right. And then you put whatever those devices are in the HD chain right ahead of the exporter. And it manages, 800 milliseconds back and forth, essentially in real time, managing that delay for you. So if you have that exporter back at the studio and it's drifting all over the time, it might make a correction every 30 seconds, every minute, or even less than that if your system's really that unstable. And if it's at a transmitter site where we don't see a lot of drift happening, it'll be there at 5 a.m. when the power goes dead and your exciter reboots, and all of a sudden your time alignment's off. Within a few seconds, it'll automatically fix it, and it does that all transparently in the HD1 chain. And that's really what most people have been most comfortable with. But there are some applications where putting it in the analog chain makes sense too. And as I said, the NRSC G203 guideline really gets into the nitty-gritty of it. It really talks about where you can put it in and what the pros and cons are, and you can really find kind of your topology that you have right now, and say, this is it. This is what I have, and then it can show you a corresponding diagram of, without tearing your entire air chain apart, where you would put the time alignment.
Alan, we're going to take one last break. When we come back, I'd like to, I forgot to mention this to you earlier, if you could have a little tip of the week to leave with our listeners, whether it's a website, a YouTube video, sign up for a webinar, whatever it may be that you think would be most helpful for our listeners to take away from today's show, that would be great. Mm-hmm. Okay?
Great.
Hey, our show This Week in Radio Tech, number 378, featuring Alan Jurison, talking about HD radio time alignment becoming really important as the number of HD radios out there becomes significant, and where it's not right, new car owners taking their radios back, taking their cars back to the dealer. So we know there's a problem. We know how to fix it. And that's what Alan has been talking about. Our show This Week in Radio Tech is brought to you in part by my friends at the Telos Alliance. And we used to talk about it. I want to mention it to you again. Their weekly newsletter, Direct Current. It's just one more look into the industry, cool facts and features. Of course, there's information about Telos, Omnia, Axia products, and about Television, our TV Solutions Group products, and 25/7 as well. So here's a quick little video about that, and then I'll have a word about Telos when we come right back.
Not much in the paper today, is there?
Yeah, not much. Seems tough to stay informed,
Like we're missing out on stuff, important stuff.
Yeah, feels like week-old news. Yesterday's stories. Half the tech stuff in here seems out of date by the time I see it.
What Kurt doesn't know is I'm way ahead of everyone else around here. Every Thursday, I get this newsletter in my email. It's Direct Current. The folks at the Telos Alliance publish this.
What Joe doesn't know is I keep one step ahead of the radio guys in this market. Every Thursday, I get Direct Current from the folks at the Telos Alliance. It's a free newsletter about radio engineering, audio, streaming, studios, everything.
Thursday afternoons, we have our department head meeting. I look like a genius, thanks to the knowledge, updates, and advice in Direct Current. Sometimes I wonder if I should tell Kirk about Direct Current. Might help him out.
I wonder if I should let Joe in on my secret. He could use a little help sometimes.
Get Direct Current in your inbox every Thursday. Read profiles of engineers and newsmakers in the broadcast community. Get technical pointers putting you and your facility at an advantage. Important industry news and views. Plus, you'll be up to date on Telos, Omnia, Axia, and Zipstream products. It's all here in the Direct Current newsletter. Subscribe online at telosalliance.com/directcurrent. That's telosalliance.com/directcurrent.
I got mine today. Did you get yours? So if you didn't, sign up for it at telosalliance.com direct current. And a little extra word for Telos. Thanks so much for making this awesome audio console. This is the Axia Radius Surface. I have it mated with our smallest mixing engine over in the rack. It's the Core 16, and it's got two mic inputs and 8 analog inputs. It's got an AES input. It's got some outputs. And, of course, it plugs right into Livewire. So in the back of this building, I've got an Axia X node back there. And I've also got a streaming computer back there that's also on the system. And this little Core 16, it's got a built-in Ethernet switch. And in this little operation, that's the only audio over IP Ethernet switch that I've got here in the building. Is the one that's built into this engine. So it's really cool, convenient, easy to put together. It let me build this radio station in less than 48 hours, and we'll be going on the air from this room tonight. We got to go to the transmitter site and grab the automation system and bring it back here. It will be on the air from right here. And yeah, it actually shouldn't take too long. And here's something else interesting that happened. We were going to mount an STL, a 950 megahertz STL dish on the roof of this building. And that plan didn't work out. Turns out the brick on this building is not going to support a big old pole being attached to it. Yeah, so we're going to have to, we've ordered a non-penetrating roof mount, like you'd use for a satellite dish, but just to put a pole up with a 950 megahertz mark antenna. But for now, we're using a couple of Telos Zip 1s to move high quality audio from here to the transmitter site. And luckily, the transmitter site has terrific internet because the tower is owned by a wireless ISP. So he's got big time internet. Yeah, right. We got fiber coming right into our transmitter building. That's awesome. Here at our studio, we've got good internet. I mean, it's cable modem based internet, so it's fine. So anyway, that we'll be on that for a few weeks or months until we get the 950 up. So there you go. Well, hey, okay, Alan, I'm sorry. We got to close out soon. Do you have a tip that you'd like to leave our listeners with?
Yeah, I mean, I don't be repetitive, but the NRSC standard that we came up with, or the guideline, I guess, nrscstandards.org, the NRSCG 203 time alignment guideline, really, as I said, is their one-stop shop. We really didn't get a chance to talk about how it all came to be, but it was a whole bunch of radio station engineers and group heads that have had a lot of experience with it, plus the manufacturers of all the equipment, Nautel and Gates Air and BE and all of those companies, and the folks at Ubiquity, Xperi. We all came together to put this document and come up with basically what everyone thinks is the best practice to solve this problem. And so I think I would really recommend downloading that if you haven't already. And look and see how your station is and say, you don't have to read all however many pages, 40, 50 pages, but, read the introductions. And then there's actually a table that says, where this device is today, go to this page and this figure, and it'll walk you through what works about that and what doesn't. I think that's a good how-to guide, how to solve this problem. And just remember, you might not have HD radio, but a lot of your listeners do.
Mm-hmm. Yep, that's true. That's true. And hey, we'll be getting it here at our stations. We'll do, of course, an HD1, and we'll do an HD2 to feed one of our new translators. So that's another reason why.
Yeah, a lot of people are doing that. It's happening a lot in small markets, the smaller medium markets. It's not all the big groups anymore. There are business plans and methodologies that are like, hey, if I can put a translator on, now all of a sudden that large cost of an HD transmitter can pay itself over a short period of time if you're able to sign on what's quote unquote like a new radio station. So they've been a really good source for different formats, different stations. It's been helpful, really helpful for AM stations that looking to get on the FM band. So, HD multicast on translators and AM translators, on FM frequencies has really been a lifeblood for this industry the last couple of years, and I continue to see that to increase over the next couple of years.
We will link that NRSC document in the show notes. And Alan, again, if you don't mind, just shoot me a quick text or email with that. I might want to make sure I get it right and don't have to. Alan, where is it? So thanks, Alan. Thank you so much for joining us from Syracuse. I really appreciate you taking the time out to join us and update us. It's been a real pleasure, and I appreciate you very much.
It's been a pleasure as always. Thank you.
All right, our show, This Week in Radio Tech, episode 378, brought to you by our friends at Lavo. Go to lavo.com/TWiRT, and they'll know that we sent you. Also, bswusa.com. You can even order tonight for another hour and 40 minutes if you're watching this live, and get what you need delivered tomorrow if you need it then. And also by the Telos Alliance, makers of an amazing array of telephone gear for broadcasters, audio consoles, of course, audio processors for AM, FM, shortwave, internet, studio, and all that. And then the other brands, 24/7 delays that you might need to keep those naughty words off the air. And our TV Solutions Group with cloud-based audio processing for your TV workflow or your radio workflow, and the IP intercom coming along. Hey, thanks a lot to them all. Thanks to Suncast, our producer. He works miracles as usual. I really appreciate him. And also to Andrew Zarian, the founder of the GFQ Network. We'll see you next week. And in 2 weeks from now, Jim Leifer, the new president of the SBE, is scheduled to be our guest. He'll be talking about some new member benefits and what's on his horizon for the SBE. And I'm not sure who's coming along next week. Maybe we'll have Chris Tarr on next week. We'll see it. We'll see you next week then on This Week in Radio Tech. Bye-bye, everybody.